Hi everyone, this video is an answer key to this worksheet on gas laws practice. Let's go ahead and get started. The first thing you should always remember is to recall the four variables that is associated with the physical property of a gas, which are pressure, volume, mole, and temperature. Now, there are a few equations that involve these variables, and the first thing you always want to do when you approach the problem is to identify which one of those variables you have in the problem. So, for example, let's go ahead and just do number one. So I have here a gas in a container occupying 5.54 liter of volume. So I know 5.54 liter, that's a volume, and then I keep reading. If the pressure on the gas is decreased from 849 millimeter mercury to 456 millimeter mercury, this is a pressure value, and this is a pressure value. Then what is the new volume? So they're asking me for volume. Okay, so the only information that's given to me is either it's pressure and volume. And the only equation that involves these two variables is what we call Boyle's law. So that is when P1 V1 is equals to P2 and P2. Now after we have identified what equation we want to use for this problem, in this case this is the equation right here. So after you have identified the equation you want to use for this problem, we need now to identify exactly which of these numbers are P1, P2, and V1 and V2. So it's all about the wording of the problem, and I can see right now at the question where it's asking for our missing variable volume, it says new volume, and new is a good indication that it should be V2, because remember that any variable with subscript 2 correspond to a final state or a final circumstance, and then 1 is the initial. So V2 is our missing variable, and now I'm looking at the two different pressure values, and it says the gas is decreased from something to something. So from is usually a good indicator that's initial, and 2 is an indicator that it is a final value. Then now, since V2 is our missing variable, this V must be V1. Okay, let's go ahead and list out all of my given and also my missing variable. So I have here V1 is that much, P2 is this much, and then, P1 is that much, and then P2 is this much, and my missing variable is V2. And it should be in the unit of liter. Remember that your unit for your final answer must always match the unit that was given to you in the problem. So in this case, if it was given to you in liter, your final answer should always be in liter. If it's given to you in milliliter, your final answer should be in milliliter. All right, the next step is for us to rearrange this equation so that we can have V2 on one side and everything else on the other side, because we're trying to find V2. So the way I'm going to do that is I am going to divide both sides by P2. Then that would give me, so I'm going to write over here, V2 is now equals to P1 V1 over P2. Once you get the equation rearrangement, you are now going to plug in what you have. So P1, 849 with the unit. Make sure you write your unit because it's going to be very easy to mix up the numbers if you don't. All right, and then the P2 is 546. It's also a good way to check your work as well if your units cancel out like so, and it definitely does. What you're left with is liter, and we do 1 liter, so that should be right. Now I'm going to punch that into the calculator, and that gives me 10.3. My final answer, liter. Let's tackle number 5 now. I'm still looking for let's see what variable is given to me in terms of the pressure, volume, mole, or temperature. So here I have a gas in the container strings from this much to this much, and these are both V. And I'm gonna assign 1 and 2 now, since I'm seeing kind of buzzwords here. From is usually corresponding to initial, so that's V1, and 2 corresponding to final, so that's 2. If it is now at negative 50 degrees Celsius, so that's temperature, then what was the original temperature? Okay, so original, here's my buzzword, so that should correspond to 1. And because that's 1, this has to be 2. All right, we have volume and temperature. The equation that we know that involve these two variables is what we call Charles' law, and it is V1 over T1 equals V2 over T2. After we have identified what equation we can use for this problem, let's list out all the given information and also our missing variable. So V1 is 1.33 liter, V2 is 0.494, T2 is negative 30 degrees Celsius, but we don't stop there, because remember, we have to convert that to Kelvin. Because if you don't convert to Kelvin, your equation is not going to work. All of these Gay-Lussac's equations, you have to have your temperature in Kelvin. So I'm going to convert that to Kelvin by adding 273, which gives me 223 Kelvin. And then my temperature, or my unknown, is T1, and that should be in Celsius. So even though our calculation, the temperature numbers have to be in Kelvin, the rule of thumb is that your final unit, or the unit for your final answer, must always match the unit that was given to you. So in this case, we were given degrees Celsius, so we have to have degrees Celsius at the end too. So we're going to find out what is the temperature, and then in Kelvin, and then we're going to have to convert it back to Celsius. Okay, let's go ahead now and do our next step, which is rearranging the equation to isolate T1. So we have T1 on one side and the rest in the other side. All right, I am going to do now what I call like a cross multiplication. So what I have is V1 T2 is equal to T1 V2. And then now I can divide both sides by V2. So that gives me T1 is equal to V1 times T2 over V2. I'm going now to plug this into what we have in the given, and I know V1 is 1.33 liter multiplied by T2, which is in Kelvin, 223 Kelvin, over V2, which is this much. When I punch that into the calculator, I should get the raw answer in Kelvin is 600 and let's say just 38 Kelvin. But we don't want that in Kelvin. Remember, we want it in Celsius. So what I'm going to do, I'm going to subtract 273, and that should give me my answer in Celsius. And I'm going to want this in three significant figure. So my answer is 327 degrees Celsius. All right, let's tackle number 9. So let's see what variable is given to us. So here we have a gas in a container exert this much amount of pressure, so that's P, at 445 Kelvin, that's T. If the temperature of a gas is increased to that much, that's also T. And based on the wording of the question, I'm going to say that is T2. And then the question asks, what will its new pressure be? So this is an indication that it's P2. So because those are both T2 and P2, these must be P1 and T1. The only equation that involves just these two variables, pressure and temperature, is the Gay-Lussac law. So which says P1 over T1 is equal to P2 over T2. All right, let's list out our list of variables. Okay, let's go ahead and rearrange our equation to isolate P2, get P2 on one side and everything else on the rest, or everything else on the other side. So let's go ahead and I'm going to multiply both sides by T2 so that this can cancel out. So then what I have is P2 is equal to P1 times T2 over T1. And now just a matter of plugging in a number. Then my final answer in 3 significant figure is 21.3. All right, let's look at number 10. And here actually I have a list of the 5 different equations that you are going to need for this particular worksheet. There's going to be a couple more coming up in the next worksheet, but for now, for this one, these are the 5 that you need to know. So let's go ahead and start, like always, but let's see what variable is given to us. So it says, consider 2 samples of nitrogen gas. Sample number 1 contains this much amount of N2, so that's N. And since it's sample number 1, I'm going to actually name that N1. And it has a volume of 36.7 liter. So that is V1, because it's part of sample 1. At 25 degrees Celsius and 1 atm. Okay, this is temperature, and then this is pressure. Now, sample 2 has a volume of this much, so I'm going to say that, V2, and then also at 25 degrees Celsius and 1 atm. Calculate the number of moles in sample number 2. All right, so then what they're looking for is N2. All right. Now we have, we got given to us basically pretty much all the variables involved in the physical property of a gas. Now, but I want to point out that there's a couple of variables that we're actually going to ignore because, take a look. You have here 25 degrees Celsius, 1 atm in sample 1. In sample 2, you still have 25 degrees Celsius and 1 atm. What this means is the temperature and the pressure remain constant, aka doesn't change. So because they don't change, they are not going to appear in the equation. That's a good rule of thumb to remember. If any of these variables don't change, they do not appear in the equation. So for example, if the number of moles doesn't change, then it shouldn't be in your equation. In this case, since temperature and pressure remains the same, they're not going to be in my equation, so I'm actually going to just ignore them. They serve nothing in my calculations, so I'm going to ignore them. So what is left that is significant for me or relevant is volume and mole. And the law that gives you the equation to solve this problem is the one that shows the relationship between volume and mole is Avogadro's law, which says, and the law that shows the relationship between volume and mole is Avogadro's law, which says V1 over N1 is equal to V2 over N2. Now let's do what we've done before. List out all our given and our missing variable, and then we can rearrange the equation, plug in a number, and finish up with the calculation. All right, let's go ahead and rearrange our equation. I want N2 on one side and all the other variables on the other side. So I'm going to cross multiply. That gives me V1, N2 equals N1, V2. Then I can divide both sides by V1, giving me N2 is equal to N1, V2 over V1. I'm actually going to switch to the middle here to plug in my number. 0.67 mole. Let's go ahead and tackle number 12. So here we have a sample of gas that has a pressure of that much. All right, let's keep doing this. That's my pressure, and a temperature of 23 degrees Celsius, that's temperature, and a volume of 1.04 liter. Okay, if the temperature is raised to that much, all right, so I have my new condition. So this should be my T2 now, and the volume increases to 1.55 liter. So that's my V2. Then what is the new pressure? Okay, new pressure, P2. So the rest then must be P1, T1, and, oh, I'm sorry, this should be V1. Okay, now it's kind of a dead giveaway that it's a combined gas law you need to use because it's the only equation you know so far that involves all three different variables, so pressure, temperature, and volume. Now, in these case, the number of moles remain constant, meaning that it doesn't change, so it will not appear in the equation, and the only thing that appears in the equation are pressure, temperature, and volume. So the equation is actually P1 V1 over T1 and P2 V2 over T2. Okay, I'm going to start again by listing out the list of my given and also what is my missing. So here's my given. Okay, here's my list of given, thanks to the magic of editing. Here it is. And now I want to rearrange the equation. So here I'm going to do the same thing as I did before, where I cross multiply, like so. And what I would get is P1 V1 T2 equals to T1 P2 V2. Okay, then I am going to actually divide both sides by T1 and V2 because I want P2 on one side and everything else on the other side. So then here's P2. All right, let's just go ahead and plug and chug. So P2. Okay, so through the power editing, here is how it should look like if you plug in the number correctly, and you should get 0.278 ATM as your answer.